This first lesson will be going over the basic graphs for calculus. These graphs are basically essential to understand when you are doing calculus, and they transcend Calc 1 to Calc 3. So the first graph is one of the basic graphs. It's just a linear function. It's just one linear function. So this is y equals x. So this graph has critical points of 1, 1, 0, 0, and negative 1, negative 1. So this graph is just a basic linear graph. You're going to see this a lot in different forms, but the most basic form is y equals x. The second graph is a normal parabola. A normal parabola. And its formula is y equals x squared. And this could be y equals x to any even power, and it'll have the same critical points. So the critical points for this parabola are 1, 1, 0, 0, negative 1, 1. So these critical points right here. And 1. And this y point here is 1. And I forgot to put the points over here as well. So this is 0, 0. Right here is 1. Right here is negative 1. The third basic graph is x square root. So x square root. So this graph right here looks like this. And its critical points are 0, 0, 1, 1, and 4, 2. It could be any, you can actually plug in numbers to get the third point, but the most basic point is 4, 2. Now, the fourth basic graph is y equals x cubed, and it looks like this. And its critical points are 1, 1, 0, 0, and negative 1, negative 1. And you just gotta remember, it has the same critical points as the linear graph, but in y equals x cubed, there's this slight curve that you should take into account. Now, for the fifth basic graph, we have y x cubed. No, x to the third power, a third root, x to the third root. And it looks like this. So y x to the third power, x to the third root, its domain is all real numbers, but if you compare that to x to the second root, the domain is restricted to only positive numbers. So the critical points are the key points are 0, 0, 1, 1, negative 1, negative 1. For the sixth basic graph, this will be of y equals 1 over x. Now, this is one of the most important graphs you're going to see in calculus because it's an inverse graph, and you're going to see this a lot when you're taking derivatives and integrals of logarithms. So this is one of those graphs that you should probably memorize. It's basically its properties, its domain, range, stuff like that. So let me draw out the graph. And one property that you should definitely memorize for this graph is that it has asymptotes at x equals 0. Yeah, at x equals 0. And y equals 0. You see, that's why they're getting closer and closer to the x and y axis, but they're never touching. So this is the graph of y equals 1 over x. And you can easily get the critical points by just plugging in values. So for x equals 0, so y equals 0, it's going to be undefined because there's an asymptote at y equals 0. You see, when x is equal to 0, there's no value for y, so it's undefined. But when x is equal to 1, y is equal to 1. So one of the critical points is 1, 1. So that's right here. 1, 1. And then you can plug in 2, which is going to just be 1/2. But you should just go the other way around and just plug in negative 1 for x. So 1 over negative 1 equals negative 1. So when x is equal to negative 1, y is equal to negative 1. So the key points are 1, 1, negative 1, negative 1, and undefined at x equals 0. So the next graph is y over x squared. This is another very important graph. You're going to see this a lot. So it's good to memorize its properties, its asymptotes, stuff like that. So it just looks like this. And once again, it has asymptotes at x equals 0, y equals 0. The only difference is that it's in the first and the second quadrant, and in 1 over x, it's in the first and the third quadrant. The graphs are in the first and third quadrant. So this is y equals 1 over x squared. And its critical points, you can once again plug in values. When you plug in 0, it's going to be undefined because at x equals 0, there's no value for y because it gets closer and closer to 0, but it never reaches 0. Now when you plug in 1, when you plug in x equals 1, y is equal to 1. So one of the critical points is 1, 1. And when you plug in, let's see, negative 1, when you plug in negative 1, you get 1 over 1, which is 1. So another critical point is negative 1, 1. And once again, it's undefined at x is equal to 0. Now, in the eighth, now I'm going to start going into the actual logarithm graphs. And you're going to see these a lot. Like, majority of calculus problems you're going to see are going to involve logarithmic problems, which include e to the x, y is equal to e to the x, and its graph looks like this. and its critical point is at 0, 1, and it looks like this. It looks like a curve. On its left side, when it's approaching negative infinity, it gets closer and closer to 0, but it never approaches 0. And when on the right side, the graph of e to the x, when it approaches infinity, y also approaches infinity. Now 9. This will be the graph of y is equal to ln of x. Ln of x is just the inverse of x. This could be rewritten as log ex, which is just the log of x, and that's why I said it's the inverse of e to the x. So I forgot to put the 1 right here. This is the key point right here, 0, 1. And since ln of x is the inverse of e to the x, that means its inverse, the values for the key point will just flip. And that's what's happened here. So the key point right here is 1, 0 for ln to the x. And in this case, as ln of x approaches negative infinity, it gets closer and closer to 0, but never approaches 0. And as ln of x approaches infinity, as x approaches infinity, y approaches infinity as well. Now, another graph that you're going to see a lot in calculus 3 is going to be the circle. So the graph of the circle, the formula is y equals x minus h squared plus y minus k squared is equal to r squared. So a y and r squared are the same thing, because when you're gonna be figuring out the formula for this the circle, you're gonna need the radius in order to find the r squared. H and k represent the center of the circle, and usually the basic circle, its center is 0, 0, and its radius is 1. So its key points are basically, let me actually draw out the circle first. So the circle, a regular circle, let me just draw a circle. Now its key points are right here. 1 key point here, 1 point here, 1 here, and 1 here. And this right here is its center. Its center is 0, 0. And right here, its key points are this right here. -1, -1. So its key points are 1, 1, 0, 1, -1, 0. Actually, it's 1, 0, 0, 1, -1, 0, and 0, -1. Another graph, similar to the circle, we also have a semicircle that you're going to see from time to time, and its formula is y is equal to 1 minus x squared, and we get this by just rearranging the original formula here to get this value. So as I said, the center of a basic circle is 0, 0. Its radius is equal to 1. So when you plug in these values, into the original formula right here. So let's do that. So it says that the original formula right here is r squared equals x minus h squared plus y minus k squared. So we know our h, so our h here is 0, our k here is 0, and then we know our radius is 1. So we just plug those values in. R1 squared is equal to x 1 squared is equal to x minus 0 squared plus y minus 0 squared, and we get 1 equals x squared plus y squared. Now you see that there's two different there's on one side of the equation we just have a constant, and the other side of the equation we have two different variables. And just like any equation, we solve for y. And so first step would be subtracting x squared. We get 1 minus x squared. And we take the square root to cancel out the square root with the y. And we get y is equal to 1 minus x squared. And this is the formula for a semicircle. Now, the graph of a semicircle looks like this. And boom, it just looks like that. Its domain, its range is restricted because of the square root, and its critical points are right here. Its critical points are 1, 0, 0, 1, -1, 0.